Hey everyone, just want to welcome you to week 5, module 5 for ME111 System Dynamics. A couple key points to go over for this week. So your homework number 2 is going to be due on Monday the 28th by 11 p.m. Please again reference back to the homework guidelines for any details on your formatting, grading, and submission. If you have any questions further than that, please feel free to email me or message me on Teams as well. You should have already seen your graded homework number 1, so you'll understand exactly what we're expecting. Also, please feel free to contact the TA. He is the one who's going to be grading your homework if you have any specific grading questions. Another note, we have quiz number 5. It's going to be released this week, and that'll be due Friday by 4 p.m. And the big ticket item this week is we have exam number 1. So this is your first exam. So the way this is going to work is you're going to have 12 hours. Now, this exam is typically designed as an in-class exam to be completed in 90 minutes. But I do understand with all of your schedules, your in-person classes, your online classes, and the fact that you now need to upload, scan this, and get it into Blackboard, I'm giving you 12 hours as compared to 90 minutes. So even if you have other classes throughout the day, or you have any issues uploading it, internet access, 12 hours as compared to 9 minutes should be plenty enough time to complete this. It'll be two questions for the exam, and these are going to be very similar to the questions you've seen in your homeworks, as well as in the example problems I go through in class. Also, reminder that my office hours are Tuesdays and Wednesdays from 9:30 a.m. to 10:30 a.m. If these don't work, please feel free to message me, send an email, message me on Teams, and we can find a time that does work for us. I will make myself available for you guys for any questions you have, anything you need to go clear up as far as the material for this course. My main objective is that you understand the material and have a good comprehension for system dynamics. So please message me if those times don't work, and we'll find a time that we can chat one-on-one or in a group setting in order to make sure that you understand all the material that's being presented to you. So for this week, we're going to start module 5, and what we're going to look at is block diagrams, state variable models, and simulation methods. A lot of what we're going to be spending time on this week is MATLAB and Simulink related. So I'm going to post a lot of different links to resources, videos. I'll go through some example stuff within MATLAB itself so that you can understand how we can utilize this as a tool to solve these different problems and functions. So far, we spent a lot of time doing hand solutions. I want to show you how to do numeric solutions as well, utilizing MATLAB and Simulink. So by the end of this chapter, what we should be able to do is describe a dynamic model as a block diagram, derive system transfer functions from a block diagram, convert differential equation model into a state variable form, express linear state variable model in the standard vector matrix form, apply SS data, TF data, and IEG and initial functions from MATLAB to analyze linear models, use the MATLAB ODE functions to solve differential equations, and also now learn Simulink, use Simulink to create simulations of dynamic models. So we'll be going over examples of all of this in my lecture slides that I'll be posting and some of the videos that I'll be posting up, as well as my solutions. So we're going to break this chapter, this module, down into 3 different sections, 1, 2, and 3. So this is module 5.1. In this module here, we're going to focus on transfer functions, block diagram models, and state variable models. So this is going to follow along with sections 5.1 and 5.2 in your textbook, transfer functions and block diagram models in 5.1 and state variable models in 5.2. So for dynamic models derived from basic physical principles, they can appear in several forms. One form is a single equation, which is called the reduced form. Another as a set of coupled first order equations, which is called the Cauchy or state variable forms. And third as a set of coupled higher order equations. So these are the 3 different forms that we may see this appear in. So this module is going to be broken down into 3 different parts. Parts 1, parts 2, and parts 3. So part 1 is required to understand part 2 and 3, but parts 2 and 3 are independent of each other. So a little overview of what we're going to cover here. In part 1, this is going to include sections 5.1 and 5.2 from your textbook. We're going to introduce block diagrams, so we'll be looking at a bunch of different block diagrams, which are based on the transfer function concept and the state variable model form. The block diagram is a way of representing the dynamics of a system in a graphical form. So a lot of times it's hard to really visualize what's going on, so this will give us a visual that we can kind of see what's going on with an entire system. So the block diagrams will be used often in the subsequent chapters to describe dynamic systems, but they also are the basis for our Simulink programming. So what we're going to learn with these block diagrams and how to draw things in block diagrams is going to directly transfer over when we start utilizing Simulink. So like I said, a lot of this chapter, in this module, we're going to spend looking at the MATLAB coding in Simulink, and I'll go through some specific examples for simple problems so that you can understand where to get all the components from, how to open this up within MATLAB, and everything you're going to need to know to solve these problems. So part 2 is going to include sections 5.3 and 5.4 for this module here. This is going to deal with linear models. So while the analysis methods of previous chapters are limited to linear models, the state variables form can also be used for solving these nonlinear equations. When we get to section 5.4, we're going to introduce MATLAB functions that are useful for solving these nonlinear differential equations. And lastly, we get to part 3. So this is going to include sections 5.5 and 5.6 from your text. This is where we start to introduce Simulink. So this is going to provide us with that graphical user interface for solving differential equations. So we kind of learned how to draw out these block diagrams by hand. Now, how do we get them into our numeric solver, into MATLAB, and specifically into Simulink? So in section 5.5, we're going to begin with solving linear equations so we can check the results with our analytical solution through Simulink. And then 5.6, we're going to take a look at some of these nonlinear equations and expand into that utilizing Simulink. So that now brings us into module 5.2. So 5.2 here, specifically state variable methods with MATLAB, and 5.4 is going to be MATLAB for ODE functions. So this brings us into step 2. We'll start looking at these state variable methods with MATLAB. So within MATLAB, there's a couple different functions we're going to utilize within this: the step, the impulse, and our LSIM functions. These can be used with these state variable models. However, the initial function, which computes the free response, can be used only with a state variable model. MATLAB is also going to provide functions for converting models between state variables and transfer functions. So we can recall that to create an LTI object for the reduced form, we have an example over here, our 5 x double dot plus 7x dot plus 4x is equal to f of t. Then we can get it in our transfer function form here. X of s over f of s is equal to 1 over 5s squared plus 7s plus 4. So we've gone through this in the previous sections and previous chapters here. Now we're going to utilize MATLAB for this here. So we'll use this TF numerator denominator function within MATLAB here, and this is how we do it for this problem here. So you can see we have our whatever our variable name is here that we want to name it, we're calling it sys1 here, is equal to this TF function of, now we have right here 1, which is our numerator, and our denominator here we have in brackets because we have 5, 7, 4, so we can see there's our 5, 7, and 4 right there. So the results of this, we have our LDI object that describes the system, the transfer function form we have shown right here. So we'll be going through a bunch of different MATLAB codes and commands and variables and functions that we can utilize to solve these problems. So last section within this module, module 5.3, state variable in MATLAB and ODE functions in MATLAB as well. So 5.5 is when we start to get into Simulink for linear, and then we continue on to Simulink for nonlinear, and we'll talk just briefly about some vehicle suspension simulations in our case study in 5.7. So part 3 for our Simulink methods here, we're talking about Simulink and linear models that we're going to start off with. So Simulink is something that's going to be built on top of MATLAB. So you must have MATLAB to use Simulink, and if you download the student version of MATLAB from UVM, you can also make sure that you have the Simulink, and I'll be going through this in a couple different video solutions to show you how to get Simulink into MATLAB, how to call it from MATLAB. So this, once we have that installed and everything's working from the UVM download, this Simulink is going to provide us with a graphical user interface that uses various types of elements that we're going to call blocks to create a simulation of a dynamical system. So we can create this graphical simulation using these block diagrams for simulation of our dynamic system. So again, this gives us a little bit of visual. So sometimes these problems become very complicated. It's hard to just look at the equations and understanding really what's going on. But if we can look at an overview through a block diagram, it sometimes helps simplify and wrap our heads around what we have going on. So, for example, one here we have a 1 block type is a multiplier, another one performs a sum, another one is an integrator. So all these different blocks will perform different functions within our dynamic system in this block diagram. So this graphical user interface is going to enable us to position these blocks, resize them, label them, and specify the block parameters and interconnects between them. So we can move this around as we see fit. Again, it's a graphical user interface for programming, which makes it easy for us to move things around and have it set up so that it makes sense to us, and not only for ourselves to follow along with our own work, but somebody else to easily follow along. So we can label things, change names, expand them, so that somebody can look at it and understand what the system is and how we set up our solution. So here's just a quick screenshot here of what the Simulink browser library looks like here, and some of these blocks that we're putting in. So you can see over here on the left side under Simulink, we can drop down. There's all these different categories that we can go through and look at things, and we can click on those. If we clicked on continuous here, we went in here, we can say, okay, maybe I want to come up with a derivative function. So I can put this in here. I'll have a function that goes through this derivative with respect to what I want. You can always double click on these blocks to set parameters. And again, we'll go through this in a little bit more detail in some of my videos throughout this module.